So it's good to see y'all again. I'm Natasha and welcome back. So today we're going to continue our fifth chapter in its complex numbers and quadratic equations as usual. So, today we're going to discuss how to find the argument of a complex number. Like we discussed about the argument of a complex number, principal argument of a complex number. Now we're going to, discuss. We've discussed about all these things. So now we're going to find that how to, find out the argument of a complex number. Okay. So, we'll be discussing about the main three steps in, finding the argument of a complex number. And so, without wasting our time, let's get started. Okay, so first of all, let me write the heading. What is it? It's, how to find the argument of a complex number. So, I'm just simply going to write finding the argument of z. Okay, so this z is a complex number to us, okay? And let's say this complex number z is equal to x plus iota y. Okay, so first thing's clear that this x is the real part, y is the imaginary part, right? Okay. So I hope this is clear. And so now the next step is, okay, so first we'll be discussing about the first step. First of all, about the first step. Okay, so what's the first step? First step is related to tan theta, okay? This tan theta is something that we're going to discuss about in, the first and the third step, okay? Third step will be in which we'll finally, finally finding the argument of the complex number, okay? Yeah, so in the first step, we have our theta, okay? We have our theta, which is equal to tan inverse. So let me write, we have our theta, or wait, let me write it from argument, okay? So, we're finding the argument of z. So, argument z is equal to theta, right? And this theta is equal to the tan inverse. Okay, so can you just guess what will be here? Okay, so these two things are given to us, that is y and x. So, we'll be first writing the imaginary part and then the real part. So what is it going to be? It's going to be y by x, right? As it's the imaginary part, so we have written it first. And then, we've written in the numerator and this x in the denominator, okay? Okay, so this is going to be the first step. And then in the second step, there's something different we have to discuss. But before moving on, to the second step, let me write it, second step. Okay, so before moving on to the second step, I have something to discuss right here, okay, this tan inverse thing. Got it? Okay, so let's discuss it. Okay, so first of all, let's say that we have, let me just make this line again. Hope to not make mistake this time. Never mind. Yeah. So, I know it's not straight, but, that will work. Okay, so what we have here is the x-axis and this y-axis, okay, as we already know. One new thing that I want to tell you is, let's say this is a O. Okay, there's nothing to say. It's already O. It's, as it's the origin. So we're always going to represent it from O. And let's say we have a point P, which is, for this x and y, okay? X and y, right? And if I'm going to join them, this line. This OP line, we already know that what we call it as the R, right? The R, as I discussed it in the polar form of, let's say, Z. What we saw was that, this X was equal to R cos theta. This Y was equal to R sine theta, right? Yeah. How is it? So this was R, right? So one thing that this OP is equal to R, and this R is, equal to the mod Z, right? As we all know, the modulus of the complex number Z. Okay, so it's the length. And if I'm gonna, make a line right here, just a triangle here. So what I'll say, this is X and this is Y. So, how did I got this thing, okay? How did I got this thing? So first of all, this thing, this cos theta and sine theta. This cos theta is for X and the sine theta for Y. So R cos theta and R sine theta. So what I did here was okay, so I did this. So, okay, can you tell me like this X by R? This X, oh, wait a second, let me write it again. Just wait a second. Yeah. So let's continue. X by R, okay? This X by R. So X is going to be R, the base. And this R is going to be the length. Yeah. Or in other ways, I can say that as a diagonal or something else. But, I'm just going to say this has the length, the R. So X by R, which is going to be equal to, what is it going to be? Of course, it's going to be cos theta, right? And this Y by R is equal to sine theta, right? This Y by R is equal to sine theta. Okay, as we all, I think we have discussed this kind of things, in physics too. And so that will be like, just exactly clear to us easily. Okay. Yeah, so let's move on to the second step, as I think that first step is clear to us. Okay? Okay, so what I can say that this X is R cos theta and this Y is R sine theta, okay? Right? Is it clear? Yes, if yes, then let's move on. Okay, so let's talk about the second step. In the second step, what do is that we identify the quadrant. Like, is it in the first quadrant or the second or third or the fourth? Okay, so, in the second step, we, identify. To identify, we have to identify the quadrant. The quadrant, okay? So for this thing, what am I going to do is, okay, we have some kind of things, okay? I'm just going to tell you, wait a second. Okay, so let's make a small thing here, okay, as a graph. Okay, so this is going to be our first quadrant, this is going to be our second quadrant, this will be the third quadrant, and this will be the fourth quadrant, right? Yeah. So this is clear to us. Do you know about these things? A, S, T, C. What is this? A, S, T, C. What is this thing? If like we haven't discussed about those trigonometric things, the trigonometric functions, or you can say just directly the trigonometry. So, like these things are discussed in, that chapter, in that topic. But, I'm going to discuss it a little bit here. Okay, so let me tell this AST. What is this AST? This AST, is for, A is, let me tell you what are their full forms. A is for all, S is for sine, T is for tan, C is for cos. Okay, is it clear? If yes, then let's move on. So this AST it's kind of a chart, or maybe I can just directly say the diagram, okay? The diagram, right? Yeah, so this AST, or I can say it as the cast. Cast is from, this CAST. Cast diagram, or I can say it as the quadrant rule. Quadrant rule, okay? Diagram in here too, okay? Whatever. Yeah. So, what is this ASTC or this this CAST, cast? So, this diagram is it's like used to see like in which quadrant those trigonometric ratios are positive. So did you get this? What is this thing? What is this thing? All is that, okay, I'm gonna, make it here too. Okay, how about making it here? I think, yeah, I should make it here. Yeah. So, so this A is that all is positive in the first quadrant, okay? All is positive. All is positive in the first quadrant. Wait a second. Yeah. In the second quadrant, this S is for sign. So sign is positive. So in the second quadrant, sign is positive. And in the third quadrant, 10 is positive. 10 is positive. And the fourth quadrant, which is C is for cos. So in the fourth quadrant, is saying that cos is positive. Okay, so if these things are positive, then what are going to be the negative? Okay, in the first quadrant, everything is positive. So there will be like nothing, that's going to be like negative. So in the second quadrant, if sign is positive, so let me tell you that, the cos and tan are going to be negative. C and T. C and, okay, I don't think there's any need to write it because I'm saying it. And, there's not too much spaces left. And second thing, wait a second. Okay. Just let me pick up the marker. Okay, I'm really confused. Okay, I'm going to just clean it from my hand. Okay, another one fell. Is there anyone left? All the three have fallen. Just wait a second, let me just pick up the markers. Yeah, so I'm back and hope these markers won't disturb us. Okay, so sign is positive, all is positive, right? Yeah. So, here in the second quadrant, okay, let me write it here, okay? In the first quadrant, second quadrant, third quadrant, fourth quadrant, whatever. Okay, in the first quadrant, cos and tan. Cos and tan are, negative. They are negative. What about the second quadrant? Just wait a second. How about we say this, okay. Let me write it again. It was confusing. Okay, things are falling again and again. Yeah. So, in the first quadrant, like everything is positive, like all is positive. Cos, sine, tan, and cos, sine, and tan. That's all we have for now. Yeah. Okay. Everything's positive, so all positive. Second quadrant, cos and tan are, negative. What about the third quadrant? The third quadrant, as 10 is positive, so sine and cos, they are negative. Sine and cos are negative. Sine and cos are negative. And in fourth quadrant, guess what? If the cos is positive, then what is left? Sine and tan. So it's really easy to guess, like, of course, the sine and tan, they're gonna be negative. So whatever, overall, whatever's left, so, that will be considered as a negative, okay? Yeah. So, so I hope this thing is clear to us, this ASTC thing. And, the short, you can even, they're like, a lot of names have been, have been here for this ASTC thing. Like, as per my study, I searched it. And, found out, that you can even say it as that all students take calculus. That was kind of, strange, like all students take calculus. I even heard that this add sugar to coffee or any other thing, just to remember this ASTC thing. So, but it's really, it's a reality. In reality, this A is for all, S is for sine, T is for tan, and C is for cos. So, through this way we can remember it. Or if that all students take calculus is, another way to remember it. So, if it's more better for you, then you can just remember it like this way. For me, it's this one, okay? And I think that's the best one to remember, Yeah, so let's get rid of this ASTC thing. And now let's get back to, complex numbers. Second step, so to identify the quadrants. So, after identifying the quadrant, is it first? Okay, we'll identify the quadrant through this ASTC thing, okay? If it's gonna be, if let's say this both, what we can see here is this X and Y, both are positive, right? So what I'm going to say that this complex number is actually, in first quadrant. First quadrant, right? Yeah, this is totally clear to us, right? As both of them are positive, cos theta 2 and sin theta 2. But, so what we'll say that this is in first quadrant. But if sin theta is negative, then where is it going to be? And if we have a positive cos theta and negative sin theta, let's say positive cos theta and negative sin theta, then it's gonna be in the fourth quadrant. As in the fourth quadrant, cos is positive, okay? That depends on, this ASTC thing. Okay, so let's get to the third and the last step. So this third step is it's different from these two steps. There's just a little bit of difference in them. So let's see what's the difference. No, there's not too much different. There's nothing too much different in it. So as far as you remember, or let me just say as far as we remember. Yeah. So how about I make it again? Okay. I want to make it a little, huge, a little big. Okay, so what I'm going to say is, in the third step, after, this finding this tan, the theta, and, after identifying the quadrant, when we come to the third step, in the third step, we usually write, we'll be writing the final argument as per this chart, I can say. Okay, do you know about what chart am I talking here? Okay, as you remember, in the previous video, I, drew something that was similar to this. And, let me tell you, what was it? Yeah, it was this first quadrant, the second quadrant was there. the third one, and the fourth one, right? Yeah, so what I wrote here was theta. Here it was pi minus theta. And here we have the pi minus theta and the negative. And here I have the negative theta, okay? Yeah, so this is the thing, we're gonna write the final argument as per this chart, okay? Yeah, so what is this thing? We have like already discussed about this. So, this is like the third step. This is the third step, right? Okay, if this is clear, then, let's move on. Yeah, so this theta thing is like wherever the theta is, pi minus theta, okay? Okay, so if we know this pi, if I'm going to say what's going to be pi by 2, it's going to be 90 degree. Pi by 4, what is it going to be? 45 degree. If I'm going to say pi by 6, then it's going to be 30 degree, right? We all know these things, right? So we'll be using these things, and we'll solve a question too, but not in this video, in the next one, okay? So in which like these are radians, we all know that, radians, and this in degrees, okay? Yeah, so I think that's enough for today, and we discussed these 3 steps, and we'll be like using all these 3 steps while solving any question which is related to this topic, like where we're finding the argument of the complex number z, or if we have any other complex number 2, that doesn't matter. Okay, so thanks for watching, and have a great day.